Hello everyone, let's try to solve one more question. This is the second question that I am solving from the chapter Basic Concepts of Chemistry. And all these questions came in JEE Mains 2026 January attempts. Why am I solving these questions? Means it will see, if you solve previous year questions, then you'll get to know what type of patterns of questions they are giving in the exam, right? So it's better before writing the exam, it's better to solve the previous year questions. That's why for your practice, I'm solving the previous year questions one by one. So yesterday, like in my last video, I have solved this particular question, and today we are going to solve one more question, which is basically some sort of same way we'll solve. Okay, same method. And yeah, so let's read the question before. Yeah, this came in 22nd January evening shift. Okay, so here they have given this equation, which is balanced one, and 36 grams of A molar mass also given, and 56 grams of B, and that molar mass also given, are allowed to react. Which of the following statements are correct? So you need to read the question properly. Like sometimes they might ask incorrect also, right? So you need to read the question properly. Here they were asking about correct statements. So here they were talking about limiting reagent, and they were talking about how much of AB2 will be formed, and they were asking about molar mass of this AB2. All these things they were asking. Like you will get to know all of these things if you know the limiting reagent is A or B, which is limiting reagent. If we get to know, according to that limiting reagent, reaction proceeds, right? So we can conclude which of the following is, like, we can conclude all of this by knowing the limiting reagent. They were asking about limiting reagent also first. So let's in order to get to know which is limiting reagent, first we need to find out number of moles. Okay, after finding number of moles, we'll get to know which is limiting reagent. So let's try to solve. First, let's try to solve for number of moles of A, which is weight by gram molecular weight. They have given both in the question itself, which is 36.0 grams, 36 grams, and molar mass they have given 60 gram per mole, right? Here this will get cancelled out, and you can cancel in 6 table, right? 6 6 are 36, 6 tens are, which is 0.6 moles. So you have understood, like, you have got number of moles of A is 0.6 moles, and number of moles of B is what? Same thing, they have given all the information, 56 grams by 80 gram by 80 gram per mole, है ना? So here you will get, you can cancel it in 8 table only. 8 sevens are 56, 8 tens are, which is 0.7 moles. Fine. See, there are two ways in which you can find out which is limiting reagent. I'll tell you both. See over here, you just divide the number of moles with stoichiometric quotient. Okay, stoichiometric quotient means this before, like, with A how much is there? 1. Stoichiometric quotient of B is 2, right? So for A, what is the number of moles for A? 0.6. What is the stoichiometric quotient? Which is 1, right? So 1, which is 0.6. For B, number of moles are 7, and stoichiometric quotient is 2, right? So here if you find out how much you'll get, 0.35 something you'll get, and you can see this is the lesser value than this. So you can say B is the limiting reagent over here. B is the I mean the amount of this reactant B is limited, right? And so you can say this is excess. This is the limiting reagent. This is what we have solved in above question also. Same question, I mean similar question. We have found the limiting reagent, and then we have proceed further. So same way we have found B is a limiting reagent. So you can say this statement is wrong, because here they have given A is the limiting reagent, but here we have got B as a limiting reagent. So next, so let's solve the next part here. And yeah, I have told you, like, I I told you, like, I will explain both the ways, right, in order to check the limiting reagent. So this way you can check by using by calculating number of moles by stoichiometric quotient, or by this equation you can say 1 mole of A, 1 mole of A requires 2 moles of B, right? 2 moles of B. And here how much you have got? A 0.6. 0.6 moles of A requires how much moles of B? You can find out, right? Just crisscross. X into 1 is equals to 2 into 0.6, which is 1.2 moles. So you are getting, for 0.6 moles of A there should be 1.2 moles of B, but we have only 0.7 moles only, right, for B. That's why this is the limiting reagent. This is how you can check, this or this method. You can prefer any one of these methods in order, which this is a real, I mean this is easy, right? This is also simple only, but as per your wish, whichever way is it possible, you can choose that thing, okay, in order to find the limiting reagent. So that's how you can check. Here these many moles of B required, but they have, but we have only 0.7. That's how we can say this is limited. And here they were asking, let me add one more slide over here. So now let's try to find out the grams of AB2, okay. So let's solve. Here the equation, let me write it over here, whatever they have given. Here this is A plus 2B gives AB2, right? So as we know that B is the limiting reagent, so we will write according to B only. So I mean, what does that mean? Means, see here, from this equation we can say 2 moles of B produces 1 mole of AB2. So here we are writing according to the reactant B, because as it is a limiting reagent, okay. And here how many moles are there for B? 0.7. So for 0.7, how many moles? 0. Moles, 0.7 moles of B requires how many moles of this AB2? I mean, how many moles of this AB2 will be produced? You can say just X, or else you can just solve like this, which is 0.7. X will be 0.7 by 2, which is equals to what? 0.35 moles. So for 0.7 moles of B, 0.5 moles of AB2 is produced, है ना? So here, as you have got number of moles of AB2 produced is 0.35. If you know the number of moles, you can easily find out the weight, right? How much mass or weight, whatever. So here it will be, number of moles will be weighed by gram molecular weight is equals to 0.35, and here weight will be 0.35 into what? Gram molecular weight, है ना? So now what is the gram molecular weight? So you can find AB2 ka gram molecular weight means a molar mass of A is 60 plus 2 times of 56. So gram molecular weight of AB2, that I am finding. So how much you will get over here, which is nearly 220 gram per, not nearly, exactly. So it will be 220 gram per mole, okay. So here, now what you'll do, you just multiply that value over here with 0.35 into 220. So now you'll get, which is 77 grams, okay. So let's check how much they have given in the option. Yeah, they have given 77 grams only, so that's why option B is correct, okay. So we have solved till two statements, and let's solve. So here this is also we have solved. Molar mass of AB2, what we have got? 220, but they have given 140, so this is wrong. And here they were asking 15 grams of A is left unreacted after the completion of the reaction. See here, B, as B is a limiting reagent, B will participate totally, I mean B will react totally. There won't be any unreacted part of B. But as it A is excess reagent, so after reaction happens, there might be some sort of A will remains unreacted, right? So here they have given 15 grams of A is left unreacted after completion of the reaction. So now we need to check this thing. So how we need to check? Let's see. So here we have this equation, right? So here we are solving for the next statement. From this statement, what we can write? 1 mole of A, which requires 2 moles of, which reacts with 2 moles of B, right? So now we don't know how much moles of A got reacted, but we know how much, how many moles of B got reacted? 0.7 moles. So this way we can find out the number of moles of A got reacted in the reaction. Okay, so again crisscross method, which is 0.7 into x, 0.7 into 1, right? X is equal 0.7 by 2. Fine. So this is how you can solve. Here we'll get 0.65 moles consumed in the reaction, in the reaction. 0.35 moles of A consumed in the reaction. So how much mass left? How you will find this? Tell how many moles were there initially for A. For A, 0.6 moles are there. 0.6 moles, and how many moles got reacted? 0.35. So if you subtract this, then you will get 0.25 moles, right? 0.25. This is not mass left. This is let me. So here it will be, so here it will be remaining moles of A. Okay, so here you have got number of moles which got remained, which is 0.25. From this you can find how much mass left, right? This is the number of moles. You can find how much mass left by multiplying this with gram molecular weight, means molar mass of A. Molar mass of A is 60, so you can multiply 60 over here and we'll get 15 grams. Okay, so that's what they were mentioned in the statement D, I hope. Yeah, 15 grams. That's why the option D is also correct. So option which are the following options are correct? Here the options are correct. B and D. B and D are correct. So I hope you have understood how to solve. I just tried to explain you each and every part in detail. Okay, so I hope you have understood each and everything. So if you didn't able to understand anywhere, you just let me know in the comment section. And you if you think these videos are helping you out, just let me know in the comment section, which will which will give me some sort of motivation to create even more videos. Okay, and yeah, that's it for this particular video. And just let me know in the comment section on which chapter you need, for which topic you need a detailed solution, detailed video solutions. Okay, so I'll try to create on those particular chapters first. Okay, I hope you have understood all these things, and we have solved two questions from this particular chapter, which came in recent JEE Main 2026 paper. So yeah, that's it for this particular video. We'll solve one more question, this question, in my next video. So yeah, that's it for this particular video. Just take care of yourself and be kind. Bye.